Today's lesson is about adding rational numbers. Your learning target says, I can use vector diagrams to correctly add rational numbers. All right, let's start with this first problem. We're going to write an addition expression to describe the situation, and then we're going to use a vector diagram to find our answer. So it says Roger owes his mom $5. When you owe somebody, it is implied that you have a negative number. And this is an addition problem. He's going to borrow another $6. So I'm going to add a negative 6 to that. All right, it's time for us to use our vector diagram. We set that up on a number line, so you'll see one down at the bottom. We're going to always start at our 0 mark. And this first integer, this -5, the negative tells me which way my vector or my arrow is going to point, and the number tells me how many places. So the negative means I'm going to move my arrow to the left 5 places. So I'm going to start at 0 and I'm going to move left 5 places and lay it down right there. And then I'm going to start where I ended, and I'm going to add to that a -6 vector. So I'm still moving to the left, this time 6 spaces, 1, 2, 3, 4, 5, 6. I'm going to end about right here on my number line. That's a -11. So my answer is -11. Let's try this again. This time we're going to use some rational numbers. We're still going to write an addition expression, and we're still going to use our vector diagram. So it says a toddler grew 2 1/4 inches. So if they're growing, we're implying that that is a positive 2 1/4. That's a 1/4. And that's an addition problem. Another 1 3/4 inches the next year. And we want to know how many inches did the child grow in those 2 years. So on my vector diagram, I'm going to start at 0. And this time I have a positive 2 1/4. So that means I'm going to move my vector to the right 2 1/4 spaces. So I'm going to try to do this precisely. 1, 2, and about a 4th. So I'm going to stop about right there. And my second vector is going to start where that one ended. I forgot my little arrowhead. And I'm going to go 1 3/4. But I might choose to do that in a different order, because if I go from the 1/4 mark, 3/4 marks, or 3/4 spaces, I'll go up to the whole number 3. So that's 3/4, and one more would leave me at 4. So what I did was I dealt really with these fractional parts first, and I put them together to make my whole number, and then I added on the extra 1. So I believe my answer is 4. All right, on this one, we're going to try a different view of our vector diagram. So we're still going to write our addition expression. We're still going to use a vector diagram. It's just going to look a little different this time. All right, so we have a submarine starting at ocean level, and it's going to descend 1,200 feet. So that's implying it's a -1,200 feet. And then it's going to descend, again, a -500 more. All right, I'm going to try a vector diagram that's vertical this time because it just seems like it's appropriate for a submarine. And here's ocean level, that's at 0. So this is -100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000, 1,100, 1,200. All right, so this is -1,200. And I went, oh, let me undo that. And I went down 1,200. And that's where I'm going to start. And then I'm going to go down another 1, 2, 3, 4, 5, down another 5. And when I'm done, I believe I'll be at a -1,700 feet. All right, so for this one, we're still having an addition expression. We're still using a vector diagram, but you're going to see that there's a difference in this problem. So Juanita's score was 5 over par, so that implies she has a positive 5. And I know it's an addition problem. And that's on the first 9 holes. And her score was 4 under par on the second 9 holes. So that implies it's a negative 4. What was her ending score? So I'm going to go ahead and start at 0 like I always do with my vector diagrams. My first number is a positive 5, so the positive tells me I'm moving to the right, and the 5 tells me 5 spaces, so I'm going to make my arrow go until the 5. And then to that I'm going to add a negative 4, so I'm going to start here where I ended, but this time my negative says I'm going to move to the left 4 spaces, 1, 2, 3, 4, and I'm going to end up right here. So it looks like my answer is going to be a positive. Whoops, let me undo that. A positive 1. I think we've done enough of these together now. I want you to try this one by yourself in your notebook. And when you're ready for checking, come back. So pause me now. All right, so you were supposed to write an addition expression. You're supposed to use a vector diagram. So let's see what happens with this one. If a balloon is rising, that implies we have a positive 10.5. And I know this is an addition problem. And then it descends 2 1/4 feet. So that implies a negative 2 1/4. All right, I'm going to change my colors and start my vector diagram. I'm going to start at 0 like always. My 10.5, the positive means I'm going to move to the right. And I'm going to move to the right 10.5 spaces. So that's about right here. I'm going to estimate. My negative 2 1/4, I'm going to move it back to the left 2 whole spaces and 1/4 of another. So I'm going to move back 1 to 9.5. 2 to 8.5, and another 1/4 to 8 1/4. All right, again, I want you to work this one on your own. You're going to pause me while you do that and then come back when you're ready to check. All right, we are writing an addition expression. We're using our vector diagram. So if a team gains 20 yards, that's a positive 20. It's an addition problem. And then they lose 7 yards, so that's a negative 7. So let me get a vector diagram started here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, we're going to start at 0. My first vector is a positive, so it's to the right, 20 spaces. And that's where I'm going to start my next vector. But this time I'm going to go to the left 7 spaces. So 1, 2, 3, 4, 5, 6, 7. And so I think I went a little too far. I should end up at 13. So my answer is 13. So we can use a little bit of rearranging, some math properties that allow us to move numbers around. That would be the commutative property, by the way, to mentally find some sums. So the commutative property says that if I don't like how these are lined up and it's an addition problem, I could rearrange them. So for example, I could put the positive 2 and the negative 2 together and then not forget that I had a negative 15. Now that might be helpful because I notice that this is a 0 pair. A 2 and a negative 2, those cancel. And so I'm only left with my answer of negative 15. Similarly, Sometimes I don't necessarily have to move things around. I can just chunk them. So a -3 and a -6 have the same sign. So 3 and 6 is 9. I'm going to keep my negative. I'm not going to forget my 4. And so I'm going to think about this as on a vector diagram. I'm going to go backwards to -9 and then forwards to 4. And in your mind, you can probably figure that is a -5.